Hello once again. Welcome to the continuation on the direction or bearing of a vector that I started with you in the previous videos. In the previous videos, we started learning about finding the direction or bearing of a given vector, which we've done a detailed explanation on it, and also we've solved some examples on it as well in the previous videos. And I hope you understood it and you enjoyed the lesson as well. So in this video, I want us to solve another example on it so that you get a perfect understanding of it. So I have example 3 on the board, as you can see. So it means we've already done example 1 and 2 in the previous videos, and I will encourage you to do all to watch the previous videos because the previous videos lays the foundation, the basic knowledge and understanding that you need about finding the direction or bearing of a given vector. I've done all those explanations into details in the previous videos, particularly the first video. Okay, so please do well to watch it so that you can get a good foundation and understanding to be able to handle this session, because we are just going to apply the knowledge that we've gotten to solve the question that I have on the board. Okay, so do well to watch it so that you can be able to handle this session also. And please don't forget to like the videos and also share them after watching. And if you are watching for the first time, please do well to follow the page and also subscribe to my YouTube channel as well. Now let's go ahead and take a look at the example 3 that I have on the board. Let's read the question together and begin to solve. So example 3, it says that find the magnitude and direction of the vector BC equals to 2 minus 4. Let me read it one more time. It says find the magnitude and direction of the vector BC equals to 2 minus 4. Okay, so the question is asking us to do two things. First of all, the question is asking us to find the magnitude of the vector BC and also find the direction also of the vector BC. Okay, so the question is in two forms. Okay, so first of all, we are to find the magnitude and also the direction of the given vector. Okay, and I've already taught you how to find the magnitude of a given vector in the previous videos. Okay, we've already treated many subtopics on the vectors already in the previous videos, and one of the things that we looked at is how to find the magnitude of a given vector. Okay, so we are just going to apply that knowledge to solve the question. Okay, so if you don't have any knowledge on how to find the magnitude of a vector, just search for the videos that I've done on the vectors. Okay, we treated finding the magnitude or the length of a vector as a full topic, okay, under the vectors. So search for it and watch it so that you can get the understanding. Okay, so let's go ahead and apply the knowledge to solve the question that I have on the board. Okay, so I'm going to write down my solution, okay, so that we can begin. So the first part is saying we should find the magnitude. So we are going to start by finding the magnitude of the vector BC. Okay, so my magnitude of vector BC, okay, this is how you write it. Okay, so if you want to show that you are finding or you are looking for the magnitude of a particular vector, you just write the vector, then you put two lines beside it, okay, and that shows the magnitude or the length of the vector. Okay, so this is how you have to write it, and this I've explained a lot in the previous videos. Okay, so it will be equal to the square root of the sum of the squares of the components of the given vector. Okay, anytime you want to find the magnitude of any given vector, is simply the square root of the sum of the squares of the components of the given vector. So these are the components of the given vector, which is 2 minus 4. So we are going to find the square root of the sum of the squares of the component of that given vector, and that is what gives the magnitude of the vector. Okay, so this is my square root. So when I take the 2, I will square it. So you square your 2, plus when I take the minus 4, I will square it. So this is what you need to do. And from here, we just need to simplify further. So my magnitude of BC will be equal to, repeat your square root, then simplify what is under the square root side. So 2 squared gives you 4, plus minus 4 squared gives you positive 16. Okay, so repeat your magnitude of vector BC equals to, let's go ahead and still simplify, 4 plus 16, it gives 20. Okay, so square root of 20. I know that the square root of 20, you will not get a whole number as an answer. Okay, so either you leave it like this or you change the answer to decimals, anyone that you want. Okay, so you can use your calculator to check it and put it into decimals, so you can leave it like this and just add your units. So I have square root of 20 units. Okay, so this becomes my final answer, or better still, you can put it in decimals as I have explained. So this is the magnitude of the vector BC. I hope the explanation is clear enough and you understand also. Let's go ahead and attend to the second part of the question, which says that we should find the direction of the vector BC. And this I've taught you in the previous videos as well, how to find the direction of a given vector. So we are going to apply the knowledge to do it. Okay, so first of all, we are going to draw our cardinal points. I've explained this a lot to you in the previous videos. So I'm going to draw my cardinal points. So okay, so this is my cardinal point. Let me straighten it more. Okay, good. So this is my north, south, west, and east. Okay, so now the next step is that we are going to plot the components of the given vector on the cardinal points. So we are going to consider the cardinal points as our Cartesian plane, as we have been doing. Okay, so after we've drawn the cardinal points like this, we are going to plot the given component of the vector on the cardinal points, considering the cardinal points as our Cartesian plane. You know the Cartesian plane, you have the y-axis, the s-axis. Okay, so we are going to consider this vertical line as our y-axis and the horizontal line as our s-axis. Okay, so when I consider this vertical line as my y-axis, here will be the positive y, okay, values, and here will be the negative y values. Then when I consider the horizontal line as my s-axis, here will be my positive s, and here will be my negative s instead. Here will be the negative s, and here will be the positive s. Okay, I hope you understand and you agree with me up to this point. And this is our point of intersection, which is also the origin. Okay, and I've explained to you that what you need to do is that you indicate the origin by the first letter. Okay, so we have vector BC equals to 2, negative 4, meaning that the origin is B. We are moving from B to C, vector BC. Okay, so the arrow is moving from B to C, meaning that the origin is B. It is starting from B moving to C. That's why it is BC. Okay, so I will label the origin here as B. Okay, that's what you need to do. This I've explained a lot in the previous video, so we are just applying the knowledge here. Okay, so now let's go ahead and plot the components of the given vector, okay, which is 2, -4. Now I hope you've not forgotten that I've explained to you that the top value is the x component and the down value is the y component. So this 2 here is the x component, this -4 here is the y component. So this 2 is +2. So we come to the x component and indicate our +2 there. Okay, so if I'm to indicate my +2, it's not drawn to scale, so just with your imagination you can locate a point on it. Okay, so the +2 will be here. So let's say my +2, I'll put it somewhere here. Okay, now let's come and plot the y component as well, which is the -4. So we come to the -y axis, okay, which is this part. So my -4, let's say it will be somewhere here. Okay, so -4. So let me shift this one so that you can see it will -4. So this is my x and -y axis. Okay, good. So I've indicated my 2 and -4 on the Cartesian plane. Okay, so what you need to do now is to get the point of intersection of these 2 and the -4. Okay, so you use just some short dashes or points to trace it and you locate where they will meet. So you can see that if you use some short dashes, the 2 and the -4, they will meet somewhere here. Okay, so this will be the point of intersection of the 2, -4. Okay, I hope you understand up to this point. So now I'm going to label this point of intersection as C. Okay, why? Because we have the vector BC moving from B to C. So now you bring your line to join it like this. Very good. So that you bring your arrow. So this is how to draw a given vector on the Cartesian plane. Okay, I hope you understand up to this point. This we've explained a lot in the previous videos. Okay, so we are just applying that knowledge here. Okay, so now we are interested in finding the direction of the vector BC. Okay, and I've explained to you from the previous video that anytime you are reading the bearing or the direction of anything on the cardinal point, you always start reading from the north in the clockwise direction. Okay, please don't forget that you always start reading from the north in the clockwise direction. So if you want to find the bearing of the vector BC, we'll start reading from the north here and we'll read till we'll come and end on the vector BC. Okay, that line which shows the vector BC, we end on it, and that gives the bearing of the vector BC. I hope the explanation is clear enough up to this point. So for us to get the bearing or the direction of the vector BC, we'll read from the north till we end on the vector BC. Okay, please, I hope the explanation is clear up to this point. So what we need to do is that we need to know the angle here and also the angle here, so that when we add it, it will give us the direction of the vector BC. But for the angle here, we already know why, because the whole of this quadrant is 90 degrees. So here is 90 degrees. It is here that we don't know, so we need to find that angle, and so that we can add it to the 90 degrees here, so that we will get the direction of the vector BC. I hope the explanation is clear enough up to this point. Okay, so how do we find the angle which is supposed to be here? But we know that the whole of this quadrant, okay, the quadrant here is also 90 degrees. So if we are able to find the angle which is supposed to be here, then of course we can know the angle which is here as well, okay, so that we can use it to get the direction of the vector BC. Okay, so I will indicate the angle here as theta, so we need to find that angle, okay, and we are going to use the trig ratio that I explained to you in the previous video, which is the tan, to be able to find the angle which is here. Okay, so now before we go ahead, you can agree with me that from here to here is 4. Okay, let's look at it. It's -4 instead. Look at it. From here, the origin up to this point is -4. So it means that from here to here will also be -4. I hope you can agree with me. I'm just trying to let you know that the origin, look at the origin up to this place, the distance is -4 as I've plotted. Okay, so it's that same distance which is repeated here. So here will also be -4. And also the distance from the origin up to this point is 2. Okay, which means that the distance from here to here will also be 2. Okay, so all that I'm saying is that we can put 2 here, okay, and also here also will be -4. So let me clean this one and put it here so that you can easily understand it. The distance from here, the origin up to here, is -4. The distance from this place up to here is 2. Why? Because we plotted it from the origin to here is -4. That's why I put -4 here. From the origin to here is 2. So if here to here is 2, then of course here to here will also be 2. I hope you understand and you agree with me up to this point. Okay, so now we are going to use the tan theta to find the angle which is supposed to be here. Okay, that I've explained in the previous videos, because that is the trig ratio that helps us to be able to find the angle. I've explained why we are using the tan theta in the previous videos. Okay, so let's go ahead and solve for the value of the angle theta. Okay, I need more space to continue, so I'm going to clean this one so that we can continue from here. But let me put the vector BC, the magnitude of the vector BC, which is square root of 20 units. Keep it in mind, okay, because we are going to put it together to answer the question. Okay, so let me write it somewhere so that we can make reference to it. Okay, so let me just put it here that my magnitude of the vector BC, we solve for it and we got square root of 20 units. Okay, so that we can make reference to it. Okay, good. So I can clean this now so that we can proceed and solve for the angle theta there. So we know that tan theta, the tan theta equals to opposite over adjacent. This we've explained a lot in the previous videos. Okay, so let's come to the diagram. Considering this right angle triangle, you can see that the opposite is the 2, because the side of the triangle which is opposite to the angle theta is what we consider as the opposite. So the opposite here is the 2. Look, this side of the triangle is opposite to the angle theta, so that's the opposite. And when we come to the adjacent is the -4. But I've explained to you that when we are calculating for the angle, we don't use the negative value, we use the positive value. Okay, so you have to discard the negative from there and use the positive 4 instead of -4. Okay, again, don't forget, when it comes to calculating for the angle, we don't use the negative signs. So if there's a negative sign attached to a particular value, you discard the negative sign and use the positive instead. Okay, that's what you have to do. So please take note of that. We are going to use +4 and not -4. Okay, if here was to be -2 also, we'd have done the same thing. Would have used the +2 and not -2. Now, the sign which is attached just help us to be able to locate the quadrant which the angle is being formed. Okay, so this 2 -4, it was just to help us to draw this and locate the quadrant which the angle is being formed. But when it comes to the calculation of the angle, we don't include the negative sign. Okay, I hope the explanation is clear enough up to this point. So my tan theta equals to opposite over adjacent. So my tan theta equals to the opposite is 2 all over the adjacent. You are going to use +4. So to get my theta will be equal to tan inverse of 2 over 4. Okay, so tan inverse of 2 over 4. And from here, you need to use your calculator to get your answer for tan inverse of 2 over 4. So let me use my calculator and let's check. You can also use your calculator to cross check as well. So I have tan inverse of 2 over 4, and that is giving me 26.5650518. And of course, you don't have to write everything, so just leave it at 3 decimal place. Okay, so I'm going to write it and leave it at 3 decimal place. So I'm going to have 26.565 degrees. Okay, so this is my value of the angle theta. Okay, and I hope you understand and you agree with me up to this point. So now we can now find the angle which is supposed to be here. Okay, so the angle which is supposed to be here, we can now get it. Okay, because the theta here, the angle theta here, is not the actual direction or bearing. That is just to help us to be able to know the actual direction or bearing of the vector BC, because I've explained to you that for you to get the direction of the vector BC, you start reading from the north, so you end on the line which is drawn, which is the BC, vector BC. So we'll start reading from the north here and we'll end on the vector BC. That will give us the actual or the true direction or bearing of the vector BC. Okay, so we needed to know the angle here so that we can add it to this angle which is here, which we know to be 90 degrees, because the whole of this quadrant is 90 degrees, so that we can get the bearing or the direction of the vector BC. So until we find the angle theta, we cannot know here. That's why we found the angle theta. So now with the help of it, we can know the angle which is formed here. Okay, so let me label this angle as S, since I don't know. So it means that S plus theta should be equal to 90 degrees. Why equal to 90 degrees? Because this quadrant, the whole of this quadrant, it forms an angle of 90 degrees, or it gives an angle of 90 degrees. So the angle here plus the angle here should be equal to 90 degrees. Then it becomes a simple linear equation to solve for the value of S. Okay, so let me continue. So I'm going to say that my S plus theta should be equal to 90 degrees, and I know theta, the value, so I'll put it there. So my S plus 26.565 degrees equals to 90 degrees. Okay, from here you just need to make S the subject. So your S will be equal to 90 degrees minus 26.565 degrees, and you finally get your S will be equal to, let's use the calculator to check and know the value that we'll get. So 90 degrees minus 26.565 degrees, which will give us 63.435 degrees. 63.435 degrees. Okay, so my S equals to 63.435 degrees. Okay, so that is the value of the angle S, which is here. Okay, so now we can now calculate for the bearing or the direction of the vector BC. Okay, so starting reading from the north, will read to end on the vector BC that you've drawn. Okay, you cannot exceed it. You end on the line that you've drawn. You end on it. So it is the 90 degrees here plus the S that will give the direction of the vector BC. Okay, so I'm going to say that my direction, let me continue from here. So direction of the vector BC will be equal to the 90 degrees plus S. Okay, so which will have 90 degrees plus the 63.435 degrees. Okay, so let's use our calculator to get the final answer. Okay, so now I'm going to have my 90 plus 63.435 degrees. Okay, and that is going to give me 153.435 degrees. So 153.435 degrees, and of course you can run it to the nearest whole number. Okay, so just run it to the nearest whole number, and which will be 153 degrees. And I hope you understand and you agree with me up to this point. Okay, so this is the direction of the vector BC. Okay, so 153 degrees. So after you've done, just put the 2 in a bracket. The question asks us to find the magnitude of vector BC, which we've done so, and also the direction of the vector BC, which we've gotten now. So just come and bring your bracket and start with the magnitude that you found, okay, which is the square root of 20 units. So bring your square root of 20 units, then you bring a comma, then you repeat your 153 degrees. Okay, so this becomes your final answer for finding the magnitude and direction of the vector BC. Okay, so you put it in a bracket like this and you are done. I hope the explanation was clear enough and you understood it as well. Please don't forget to like the video and also share them after watching. And if you are watching for the first time, please follow the page and also subscribe to my YouTube channel as well. I'll see you again in another video whilst we solve another example on this. Bye bye.